Hello everyone, welcome back to my YouTube channel. In this video, I'm going to explain to you how you should answer the class activity questions. Altogether, we have 6 different questions from different chapters. Let's get started. Question number 1. A system does 1.8 times 10 to the power of 8 joule of work, while 4.15 times 10 to the power of 8 joule of heat is being absorbed from the environment. What is the change in internal energy of the system, assuming no other changes occur? Alright, so in order for you to answer this question, the first thing that you need to do is we need to look at your work and also your heat. So in this question, the system does the work, so your work must be positive. And the heat is being absorbed, so the system absorbs the heat, so your Q must be positive as well. And then you were asked to calculate the change in internal energy. Change in internal energy is delta U. So delta U is equivalent to Q minus W. So since both W and Q are positive, means that we need to just use this value as it is. So your Q is the heat, which is equivalent to 4.15 times 10 to the power of 8 minus your W is 1.8 times 10 to the power of 8. Therefore, you should get your delta U, which is the change in internal energy, is equivalent to 2.35 times 10 to the power of 8 joule. So this is the final answer for the first question. Moving on to question number 2. A big chunk of ice absorbed 5.23 kilojoule of heat at 14 degrees Celsius until it melted. What is the entropy change of the ice if the process is non-spontaneous? In order for you to answer this question, you need to first know whether the process is spontaneous or non-spontaneous. For instance, in this question, it is a non-spontaneous process whereby your delta S universe should be less than 0. So next, you need to know what is the full formula for your delta S universe. So delta S universe is equivalent to delta S system, which is the thing that you want to calculate, plus delta S surrounding. Right, your delta S surrounding can also be written as negative Q, which is the loss of heat divided by temperature of the surrounding. Alright, so what is this value? So we will assume your delta S universe equivalent to 0, so that it is easier for us to assume what is delta S system. So now we are going to calculate delta S surrounding. So delta S surrounding is negative Q. So your Q is 5.23 kilojoule because the chunk of ice absorbed the heat. From where? From the surrounding. It means that the surrounding will lose this heat. So 5.23 times 10 to the power of 3 joule. Divided by the temperature, which is 14 degrees Celsius, you need to convert it to Kelvin plus 273. So it's equivalent to delta S system plus negative 1.82295 times 10 to the power of 1. Right? Therefore, we can say that your delta S system should be equivalent to 18.2295. Okay, this value, if it is equivalent to 0, but you know that this is a non-spontaneous process whereby your delta S universe should be less than 0. In order to fulfill this requirement, your delta S system should be less than 18.2295. So how are you going to check this? So you just put any number here which is less than 18. For example, you put here is 16. So 16 minus 18, definitely your delta S universe should be negative, right? Because small number minus big number, you will get negative, which is less than 0. So this proves that your delta S system should be less than 18.2295. So this is the final answer for the second question. Moving on to question number 3, 180 gram of bromine gas is isothermally expanded to 3 times its original volume at 25 degrees Celsius. Determine the work and the heat of the reaction. The first thing that you need to do in order for you to answer this question is look at the information given. You were given the mass of the bromine gas. So from the mass, you need to be able to calculate the number of mole. So the number of mole for bromine gas is equivalent to mass over RMM. Given in the question, the mass is 180 gram. So the RMM for bromine gas is 79.904 because it's a bromine gas, so you need to times 2. Right? So from there, you will get 180 divided by 1.5981 times 10 to the power of 2. Hence, you will get the number of mole for bromine gas is 1.1263 gram per mole. So from the previous calculation, we know that the number of mole for bromine gas is equivalent to 1.1263 gram per mole. Alright, so this is an isothermal process. Therefore, you can get your W is equivalent to nRT ln V2 over V1, right? So your N is this one, the one that you have just calculated from the mass of bromine. So 1.1263. Your R is the gas constant, which is 8.3145. And your T is 25 degrees Celsius. You need to plus 273 to convert it to Kelvin. So ln volume. So V2 is 3 times original. So 3V. The original we consider as just V. Or you might want to write 1V. That's fine also. So 1.1263 times 8.3145 times 298 ln 3. Okay, so you will get 3.0659 times 10 to the power of 3. Okay, this is the work. So because this is an isothermal reaction, W is actually equivalent to Q. So the work is 3.0659 times 10 to the power of 3, and the heat should have the same value as well. So this value is for W and also for Q. Let's move on to question number 4. A 0.23 gram of sample A had a volume of 0.0785 decimeter cube at 95 degrees Celsius and 1.02 times 10 to the power of 5 Pascal. Determine the relative molar mass of sample A. Q is in Pascal. Therefore, the first thing that you need to do is to convert 1.02 times 10 to the power of 5 Pascal to ATM. So you should be able to get 1.00666 ATM. Alright, you can either do this by manual way to calculate, to convert from Pascal to ATM, or you can directly press from your calculator. Okay, next up, you need to use the ideal gas law formula, which is PV equivalent to nRT. So the pressure that you have converted is 1.00666, and then the volume given to you in the question is 0.0785 decimeter cube, which is equivalent to liter. So times your N, so you need to find what is N. Because you don't know what it is, it's sample A. So although you have the mass, you couldn't know what is your N. And the R is the gas constant, which is 0.0821. And your T is given in the question, 95 degrees Celsius, you need to convert to Kelvin plus 273. So from here, you can get your N is actually equivalent to 7.9023 times 10 to the power of negative 2 divided by 3.0213 times 10 to the power of 1. Therefore, you get your N equivalent to 2.6155 times 10 to the power of negative 3 mole. Right. So from here, then only we can get what is the relative molar mass for sample A. Okay, from the previous calculation, we get the number of mole is equivalent to 2.6155 times 10 to the power of negative 3. So you were asked to calculate the relative molar mass. So number of mole is equivalent to mass over RMM. So you already get your number of mole 2.6155 times 10 to the power of negative 3 is equivalent to the mass given in the question, 0.23 gram. So you shall get your RMM. So we are just going to swap this out. So it's equivalent to 0.23 divided by 2.6155 times 10 to the power of negative 3. So you should get your relative molar mass is equivalent to 87.9363 gram per mole. So this is the final answer for the fourth question. Let's move on to question number 5. A 2-liter mixture of ideal gas of helium, nitrogen and neon has a total pressure of 1.0724 atm at the temperature of 255 Kelvin. If the partial pressure of helium and nitrogen are 2.7997 times 10 to the power of 4 Pascal and 0.4618 atm respectively, determine the mass of neon present in the mixture. In this question, given to you is the total pressure of the gas, which is 1.0724 atm. So we can say that total pressure is equivalent to 1.0724 atm. And then the pressure for nitrogen is equivalent to 0.4618 atm, and the pressure of helium is equivalent to 2.7997 times 10 to the power of 4 Pascal. So this one you need to convert to atm, whereby you should get 2.7631 times 10 to the power of negative 1 atm. So from here, you can actually know what is the pressure of the neon. So the pressure of neon should be 1.0724, which is the total pressure, minus the pressure of nitrogen, which is 0.4618, plus the pressure of helium, which is 0.27631. So you shall get the pressure of neon is equivalent to 0.3430 atm. So from here, then only we can move on to determine the mass of neon present in the mixture. So from the previous calculation, we know that the pressure for neon, the partial pressure for neon, is actually equivalent to 0.3430 atm. And you were asked to calculate the mass of neon, right? So in order for you to get the mass of neon, so you need to know what is the number of mole. So in order for you to get the number of mole, you need to use the ideal gas law. So PV equivalent to nRT, because it's an ideal gas. So your pressure for neon is 0.3430 atm, and this mixture is being put in a 2-liter container. So 2 liter is your volume, and your N is the one that you want to calculate. R is a constant gas constant, 0.0821, and your temperature is given to you in the question, which is 255 Kelvin. From here, you can get your N is equivalent to 0.3430 times 2 divided by 0.0821 times 255. From here, you get your N equivalent to 3.2767 times 10 to the power of negative 2 mole. Once you get the number of mole, you can definitely get the mass of neon present in this mixture. Alright, so from the calculation just now, you get your N is equivalent to 3.2767 times 10 to the power of negative 2 mole of neon. So from the number of mole is equivalent to mass over RMM. Alright, so number of mole is 3.2767 times 10 to the power of negative 2. The mass is what you want to calculate, because you know now it's neon, so neon is it's just an E. So the relative molar mass for neon is 20.179. It's not like nitrogen gas, which is M2, where you need to times 2, but for neon you don't need to do that. You just have to plug in that value. So your mass is actually 20.179 times the number of mole, which is 3.2767 times 10 to the power of negative 2. Therefore, you get the mass of neon is equivalent to 0.6612 gram. This is the mass of neon present in the mixture. We are now at question number 6. Carbon monoxide and hydrogen react in accordance to the following equation. A 62.8 mole of carbon monoxide was added to 146 mole of hydrogen. When the equilibrium was reached at a specific temperature, the mixture contained 26.2 mole of methanol at a total pressure of 9.50 Pascal. Determine the Kp for this experiment. In this question, you were asked to calculate the Kp for the experiment. Therefore, you need to write the ice diagram. So in order for you to write the ice diagram, you need to write the balance equation. But given to you in the question is already the balance equation. So carbon monoxide plus 2 hydrogen gas will produce the methanol. Right, so for the ice diagram, ICE, so instead of using the concentration, because we don't know the concentration, we are going to use the number of mole. So initially the number of mole of carbon monoxide is 62.8 and the number of mole of hydrogen is 146. At the beginning of the reaction, there's no methanol is being formed, so here is 0. At change, we are going to do negative x, but here since we have 2, so negative 2x, and this one is positive x. If you read again, the question states here that the methanol at equilibrium is 26.2, means that your x is equivalent to 26.2. Therefore, this one for carbon monoxide at equilibrium is 62.8 minus 26.2, and this one for hydrogen 146 minus 2 times 26.2. Therefore, we get at equilibrium the concentration of carbon monoxide is equivalent to 36.6, and for hydrogen is 93.6, and for methanol obviously is 26.2. So we have now finished our ice diagram. But since you were asked to calculate the Kp, what we really need is not the number of mole, but we need the partial pressure. So in order for you to calculate the partial pressure, you need to have the mole fraction. From the mole fraction, then only you can calculate the partial pressure. In order for you to calculate the partial pressure, the first thing that you need to do is you need to know what is the total number of mole. So, from the calculation that we have in the ice diagram, you know that at equilibrium, the number of mole for carbon monoxide is 36.6 mole, and hydrogen is 93.6, and from the question states that the methanol is equivalent to 26.2. Therefore, we can say that the total number of mole for this reaction is actually 156.4 mole. Right. Alright, next up what we are going to calculate is the mole fraction. So the mole fraction for carbon monoxide is equivalent to the number of moles of carbon monoxide, 36.6, divided by the total number of moles, so divided by 156.4. And then you can do the same for hydrogen. which is the mole fraction of hydrogen, is equivalent to 93.6 divided by 156.4. Same goes with mole fraction for the methanol is equivalent to 26.2 divided by the total number of mole, 156.4. Alright, the next up that you need to do is you need to times the total pressure for each and every mole fraction. So the total pressure given in the question is 9.5. So I'm going to write 9.5 to each one of these. So once you have already calculated this, means that instead of the mole fraction, now you are actually calculating the partial pressure. Right. So from this partial pressure, we can now calculate the Kp for this experiment. Right, so now we are going to calculate the Kp for this experiment. So in order for you to calculate the Kp is whatever in the product. So the partial pressure of product now is methanol divided by the partial pressure of the reactant, which is carbon monoxide, plus partial pressure of hydrogen gas. But bear in mind you have 2 here, so you need to have to the power of 2. So in terms of calculating this, you need to know the partial pressure. So because we already calculated just now, so we're just going to plug in the value inside your Kp. So just like the calculation that we have done just now, this part is actually the mole fraction times your total pressure. This is actually your partial pressure. So therefore, what you can get is your Kp is equivalent to 1.5914 divided by 71.859. So you will get your Kp is equivalent to 0.0215 Pascal. So this is the final answer for the 6th question. This is the end of this week's video. Thank you very much for watching until the end. I hope this video will help you to understand more on how to answer all the questions for the class activity. Thank you for watching and see you again next week. Goodbye.